everybody. I know everybody's wondering, what's this about, right? We have been, scientists, thinking about a question for a long time. It's right here. Azure, what does that say?
How do things move on Earth and in space?
So, through a long process of investigation, we found out that things don't move the same on Earth as they do in space, right? There are some parallels, there are some things that are similar, but there are some major differences. So I want you to keep those differences in mind as I pose this problem to you. So, because we know that everything is related in some way, if we think hard enough about it, there are parallels and relationships between things, right? So I'm going to give you a little puzzle. Open up your science journals to your page. Give you a date at the top. Plenty of places to sit if you guys want to come. Okay, and I don't want you to make it look like this, but let's just put a big idea at the top and leave it blank for now. Perfect. So Ben's got a big idea and it's blank. I don't want you to write anything there yet. So your puzzle's going to be to try to figure out what the big idea is. I want you to notice the details between these items and to try to figure out what the relationship is between all of them. But it has to be done totally silently, and don't let anybody see your papers. Except the adults. Are you ready? Okay, so I'm going to show you the first one. You're going to write down either a word or a phrase to describe what you think could be the big idea. Now when I get to the next one, we're either going to say, check, oh yes, that confirms what I think the big idea is, or, oh no, wait a minute. Now I have a new idea. Okay, so you've got a list of what you think the big idea is going to be, and the list is going down. Questions? Okay, here we go. Write down a word or a group of words as to what you think it might be. Ready? Oh, not everybody has something written down, so I'm going to wait. You're going to have a list. It's not going to look like this. You've got a big idea at the top of your page, and you're making a list going underneath what you think the big idea might be. Who's got a word or a phrase written down so far? Okay. Okay, here we go. So maybe when I show you the next one, you're going to say, oh, yep, I think that's going to be it. I see a parallel, yep. Or you're going to go, wait a minute. You're going to have to come up with a new one, right? This is fun. Phrase as to now what you think possibly the big idea is. Who sees a parallel between these two? Keep your hand up if it was different than what you thought. Okay. So if Ryan put a check, that means he's, oh yeah, that confirms it. Or it maybe it disconfirms it. Those are stingrays. List going down. Big idea at the top. Big idea at the top here. List going down. Like you can see Ryan and Brian have got it. List of what you think it could be. Here we go. Okay, so we want to see chest. Yep, it confirms it or it changed it. Who has changed their what they think it is so far? Okay, good. All right, here we go, next one. Okay, so avoid writing what the image is. So we all see what the image is. What we're looking for is, what do you think is the connection, the relationship between all of the images? That's what we're looking for. Relationships. How are they all related? Parallels. Big surprise. Orion noticed something. He's going to have to keep it to himself then. Okay, so does that confirm what you think the big idea is, or what changes it? Here comes another one. Another one. Are they all related? Hayden, don't say anything. Do you have a word or a phrase to describe how you think they're all related?
Yes.
Here's another one. Ah. And another one. Another one. Don't tell us what you think. Do you have a word or a phrase written down to explain how you think all of these are related so far? And another one. Okay. So, now I want you to go to the top of your page. And I want you to write down where you had that blank. What do you think was the big idea there? How were they all related? How are they all connected? We're not going to say it out loud yet. You want that at the top of your page. Now, I can see a few of you are unsure. That's fine, because when we put our brains together, it's going to help us kind of come up with things we come up with on our own. All right. Okay, so this part's going to be with your group. So in your group, you're going to discuss what you think the big idea was and what's your evidence for that, okay? My evidence is because, I know that because part of your evidence is this, right? And part of your evidence is this. And then I'm going to ask you to do a second thing, okay? So first you're going to discuss with your group what you think this is. Try to form a consensus on that, okay? Second, I want you and your group to think of something that most people would think goes in the circle, but doesn't. Second thing is think of something that most people think would go in the circle, but doesn't. Maybe some of the adults in the room would think. They would think that, but doesn't. Okay? Now try not to let the other group hear, okay? So you're gonna do two things. What's the first thing I said you're gonna do, Tristan?
Form a consensus with your group on what the main idea is.
Right. What's the second thing, Nicole?
You're going to try to figure out things that will go in there that doesn't seem like
Okay, no, yeah, you're gonna think about what some people would think goes in there, but doesn't. Yes? Okay, go.
They're related in something that could fall or something that can...
Some are taken up and some are hard to tell.
It's gravity or pressure because when he has a soccer ball, it's higher air pressure. And when the frog is jumping, it's like gravity and also the speed. Yeah, I think that
Taking off
but
things in the air.
how would you
Put that into a word.
Aren't you technically in airplane?
Except for that would be
Yeah, I think it is like
I bet there's a word. Probably try that. Or just are you just gonna do a phrase then?
yeah, but then but if you jump off the rock, that would be suicide.
1 minute. 1 minute, scientists.
not on the ground. So
Gravity?
Yeah,
Suicide.
Bungee jumping would definitely go in there because you're still connected to the ground, even though you are. So movement on the air without touching the ground.
without touching the ground. So bungee jumping would not, because you still have to touch the ground.
And jumping would, because that moment,
Think would belong to doesn't.
Well, jumping, yeah.
but that's would go in there, but bungee jumping,
Bungee
still
jumping.
connected to the ground. You're not bungee jumping out of an airplane or a helicopter.
So how would a leaf in a tree, what would your justification be if somebody asked you to defend that? So why would someone think that fits but it really doesn't?
Because the leaf would have people would think it has something to do with air, like the leaf is falling off the tree. But it's not really jumping or like flying through the air as like some people are. It's falling. Like with all of these, they're basically going out of gravity. Well, not going out of
They're
gravity.
going against it. They're
Yeah,
working
and
counter
then
to
this
it.
one is like, and then this leaf is just coming off. It's gravity's pulling it down.
Okay, I'll buy that justification. So you're saying, let me make sure I'm hearing you guys right, that everything that's in there is counter gravity, working against gravity. And your example is something that is going with or not touching it. Okay, so that's fine. Good.
You're in it. So you can say that if you're touching anything like this, why? Those are not.
Should we share what you guys think? Okay, we'll do that too. Zeller. Okay, so TED means that everybody's eyes are right here.
Well, we thought that with our rules that bungee jumping, most people would think fit into the category, which we thought was moving through the air without touching the ground. And bungee jumping, you're still touching the ground because you're attached to a harness, which is attached to a bungee cord, which is attached to solid ground. So technically, you're not or a bridge, or yes, or a bridge. Or something, jumping into a bridge, but you're still touching the ground.
Is this feedback?
Our group had a very provocative discussion. And what we decided on was a zip line would not fit in the circle because a zip line, if you had a full image of a zip line, there'd be a pole and then a line and then another pole. And then you're touching a harness which is touching the line, which is touching the pole, and the pole's touching the ground. So technically, you're touching the ground. Same thing as bungee jumping. Well, our idea was that a maple tree with a leaf falling off of it would be some people would think that one might go in there, but it wouldn't because everything in the picture is going against gravity by like rising up or cutting through the air, and then but with the leaf, it's falling to the ground because gravity's pulling it down. So that's how they're doing it.
Hey, Ryan, let me ask you again. So what I heard you saying is that a leaf doesn't belong because leaf is being pulled down by gravity.
Yeah.
Okay, and we know that gravity's a force, right?
Yeah.
Are these things being pulled down by gravity?
Yes.
Yeah.
They're fighting it somehow.
They're fighting it in some way. Okay. Who's next?
Well, for the guy on the rock, my crew, we thought, well, he's touching the rock, which is touching the ground, and if he was bungee jumping, that wouldn't work. But if he was jumping off with a parachute, that would work because the parachute is like in the air. So if he's jumping off with the parachute, it would work. But if he's just standing off the rock and bungee jumping, it wouldn't work.
Cool. You got feedback here.
I don't know if this is really a good question, but since the parachute is touching the air, wouldn't it, the air is touching the ground, wouldn't it be touching the ground? But, well,
That means none of
came up with. So if the air is something and the air is touching the ground, that would mean you're always touching the ground. But if space is mostly nothing, and you can't touch nothing, so if you're in space, would you be touching the ground?
No, because there's different atmospheres. There's like no, it never ends. Space never
Well,
ends.
no, but would you be touching Earth's crust if you were in space?
No.
Because nothing.
Because there's floating in the atmosphere. There's atmospheres. There's different layers of the Earth. So like.
But if you were touching the atmosphere touching the ground.
Yeah, because like in space, there's nothing there, and
Yeah. So
if there's nothing,
there's nothing. Nothing.
Well, what if you're in
Nothing. You're touching
well,
nothing.
technically, if you're in
Then what's nothing?
that's gonna be
Sounds like we're ready for a philosophy course.
Yeah.
So let's get out here. Let's hear more big ideas. Have you chosen Jack?
Isn't the sun getting pulled by the sun, so that way it circles around it? The Earth is being pulled by the sun, not the sun getting pulled by the sun. Yeah.
So Ava, what I heard you saying is that all of these things will eventually come down. And the reason that Earth doesn't fit into it is that Earth is anytime in the near future not going down. And in space there is no up and down. You said Earth is up there, but not really. So that would work. Who's next?
My group was thinking, and we thought maybe skydiving would work, but it wouldn't because gravity's pulling you down. Like Orion said, the leaf is floating down. Even if you were using a parachute, you would still be floating down, and gravity would still be pulling you down.
So then Lexi, how is this different from parachuting? Did you say parachuting and skydiving?
Skydiving was a parachute.
And a leaf falling.
Yeah, that's why.
How is this different?
In a hot air balloon, there's not lifting it up.
You can, okay, you can rise, okay. What direction does this go in? Can you show me with your hands?
Up, because the fire.
Oh, it only goes up? So this is what a hot air balloon does. It goes up and it goes down, that's it? It goes like this? It can go in any direction. Okay, okay. Okay, we need another one. Who have we not heard from? Who have we not heard from? We've heard from everybody? Okay, so here's your challenge. Your challenge is to find one word that describes those categories. One word that describes all of them, and we need to agree as a class. That means you can get up and you can move. We need one word to describe all of those things. Go.
So what's your one word goal? You don't like that? What do you like?
That's something to do. It's like flying here, right? So right there, I would work because I have something to do with air.
No, we're doing something that all of those have in common. Not something that other things can fit in. All of those inside the circle have in common.
Every single one fits something. Wait, we think. What if we eliminate and you don't work? It's not to do with air. It must be the L tower because of the air. Yes, exactly. Air travels.
So you They would all fall to the ground. Which means they all move air.
Science.
It's real.
Okay. Let's see what you think. What's your word, Elton? Say it again.
Light.
What's your word? Could it be flight? Why do you think it's flight?
It depends on how you look at it.
Okay.
It's flight because the person, flight
Just a minute.
for a plane.
You know, we're all excited. Face not on Ted, but she still should have our attention right here. Go ahead.
A plane uses an engine to take flight, but like a soccer ball, it could be like the person kicking it. It doesn't necessarily have to be an engine running the soccer ball.
How did this take flight?
It's energy and energy.
How did this take flight? Who thought it was jumping at first? Okay. Now, how did this take flight? Okay, so these groups are right. It's flight. It's flight. Let's put the big idea at the top. It's flight. And I want to start to guide your thinking that way. If you were thinking air, true, they all do move through the air. But flight is really what I was going for. Let's put flight at the top. At the top of your page, big idea is flight. I'm going to get you in just a second, Michael, because I got to move this forward here. Okay, now, I want you to talk in your group about what you know about flight. In every single picture, there is an object, something is in flight, in every single picture. And they came about the flight in different ways, okay? So some of them, they're using different forces to take flight. You're gonna have to figure out what those are. But what are there rules associated with flight?
Yes.
Are there rules that say something is flying, something is not?
Yes.
How does flight work? What rules are involved? I want you to discuss this with your group. You may have some misconceptions, right? In science, before we actually learn, it's like, well, there's lots of misconceptions we're going to have to see. Are we right about that or are we not? We'll clarify those in the end. So you're looking for what are the rules of flight? How do you know if something is flying or if something is not? Quickly, yes.
Well, wouldn't another word, couldn't it be like the forces that it's using to fly? Because like the stingrays
Forces.
the stingrays are swimming fast enough and strong enough to get in the air.
Okay, does flight involve forces?
Yes. Yes.
Okay, so that's for you to discuss. So your discussion right now is, are there rules associated with flight? You just mentioned a rule. You said it involves some forces. Well, if you think that's true, what are the forces that are involved in flight? I want you to discuss it. You have 3 minutes. Go.
So that would be like its engine. And the bows are compressed on the air. And then the bird is flying with the wings. Are there any rules? If you think about the bird, it has to go up, or if it can go down, that's just not really flying. The gravity is holding it down. It's not. This is gliding. It's gliding through the tail. The bird has to go up. Technically, they need to make it fly. Is like what it is, like that. No, it makes it with what the bird with the energy. Bird? Yeah. Oh yeah. Bird eats what it's supposed to. That too. That gives it Maybe another rule of like it has to match up. It can't just be like if it's off the ground. It has to go up and down. Yeah, it just has to go up and down. It's fine if it goes like just not even a centimeter. As long as it's up off the ground, it's fine. As long as it goes up like this, that's fine. Like my hands like when you're right to blow it up, it's still going up. It's flying for a second. No, it can't. No, it can't. Doesn't fly. It has to stay in the air. You have no idea. That's how just like the stick. You have to learn about what about inertia? No, not that. No. The blimp doesn't go on itself. The hot air balloon has, I know, has fire with it.
Okay, I want to hear what you think a rule of flight is. Something about okay, this is a rule, like flight has to involve this. What do we think? These might be wrong. Doesn't matter. We're just going to throw it out there. Jenna.
Wait. Everything that flies must come down on a planet. It has to go up first.
You hearing these? Okay, how about this? I agree. I don't know. Jenna, say it again.
Wait.
This is, I agree. I don't know. What did you say, Allison?
Everything that goes first up, it has to go up before it goes down. If something's on a planet and it flies, it has to go. You have to have energy. You have to have some sort of energy.
Carson. Okay, we're doing it, right? Do you agree?
Some sort of force that
Kate.
Well, ours was you have to have some kind of force because you can't just say you're going to do something. You have to actually put energy in it, otherwise it won't work. So
Right.
you have to have force to do anything.
Gravity, because if there was no gravity, things would just float.
Floating is different from flying. I was expecting you to bring that up.
Everything that goes up must come down.
Okay, so let's pause right there, okay? So you guys are on to something. Some of those things might be misconceptions, they might not. There are some rules of flight, and I want you to discover them. Those of you that were thinking forces are involved, raise your hand. Okay, there are 4 forces involved with flight. I want you to take out your iPad, go to the library view, click on that link, and I want you to explore those 4 forces. I purposely wanted you guys to share your iPads so that you can be discussing and looking at it together.
You've exposed me.
June Engineering Challenge, I'm sorry. June Engineering Challenge is what you're going to. Yeah, June Engineering Challenge. There you go.
Hello, Tristan.
So, certain
Opening Safari. Tristan, I just don't remember in last class where we learned about 4 forces. It's gravity, electromagnetic Weight, lift, thrust, and drag.
Although some could.
I mean, we got it right.
Weight.
We only got weight right. Wow.
Weight, lift, thrust, and
I don't know, I think you guys were kind of describing thrust. You just used a different vocabulary for it.
They all act.
Drag is what is pulling it back in the air. Like if it's a flat block and it goes through, there won't be any go fast because of drag. If it was air, then sharp like a pencil is like an arrow. That's why. And that's why papers, when you try to throw things, they're not very good things to yeah.
That's the force of gravity. We would never come down. But if we don't have lift, we don't lift off the ground. We don't power. One of that is drag.
Well, they're not. I think thrust it.
You need a lot more fuel than you do here.
Of your 4 on your list, what's the fuel and the engine and the beginning of your of our 4 forces? So what's the difference between thrust and lift?
Drag. It's on an airplane. Let's see. Wings are the key.
That's why they keep holding up. If you just look out the window, you can see
Awesome. Got this whole part of the room standing up? If you didn't do that yet, please do it. Stand up. So there are 4 forces involved. There's a relationship between those 4 forces. Let's see if we can figure it out. We're going to use our hand to act them out. What do you call this force? Do it with me. What's this force?
Weight.
What would we call this force? Notice the relationship between their opposites. So we've got weight, and then what was the opposite force? Okay. What would we call this force?
Thrust.
What's the opposite force?
Drag.
Okay. Similar relationships. Okay. We're going to watch, it's kind of a silly video. Take a seat. Okay. We're going to see these 4 forces in action. And then we're going to use these 4 forces for a challenge. So I need everybody to be facing this way, please. Cross your fingers that it works. Okay, no sound, just as well. What force is in action right now?
Thrust.
Okay, so you see weight and lift, right?
Drag.
That's even better. No music and then music.
Ready? Think. What do you have to overcome in order to fly? No. Think. What do you have to overcome in order to fly? Okay, good. Now I have some thinkers because I see hands. What do I have to overcome in order to fly? Jordan, will you do the air again, please? Let's see, who have we not heard from? Jacob.
You need to defy that. Making you, you need to defy your weight.
Okay, so you need to overcome your weight, you need to overcome the force of gravity. What else? Okay, so drag is like the pull, right? Okay. Anything else I need to overcome? Okay, let's go back to our question. How do things move in Earth and space? What if I do this? Okay, remember how we tested this out earlier in the year? Like, I took like a tennis ball or something and I went like that on Earth. What would happen and why?
It would
Musashi.
go like in a start going sideways and then start going down
Why?
because of the gravity and its weight.
Okay, so same experiment. I'm an astronaut. I'm outside of the International Space Station. I do the exact same thing. I do this. What happens and why? Michael.
Oh, well, since you're in space, there's nothing in space to pull it down unless it gets really close to the sun or to any gravitational pull.
So what happens?
You push it and it will just keep going straight forever.
Forever, right? Yes, it will.
Until something.
That was, you had that misconception, and I didn't. I waited for this moment. So it will go on forever because what is not acting on it?
Gravity.
There's no force acting on it, right? There's no air that it's pushing through, right? There's nothing, okay? So, are you ready? You have a challenge. It's an engineering challenge. We're going to use the engineering design process to do that. Right? You're familiar with our process, right? Okay. So, first in our process is what? Okay, ask. So you should be asking, what's the challenge, right? The challenge is you can use anything that's here in this room today, but can't break anything, okay? And you are going to design something that overcomes gravity using the 4 forces of flight and stays in flight for as long as possible. That is your challenge. Do you have any questions you want to ask me about your challenge? Yes, it is. So that was your criteria. That's what we want. Okay, our criteria, engineers, right? We want it to stay in flight as long as possible. That's what we want. You want to probably know about your constraints, right? What questions do you have? One question? 2, good. So lots of constraints. Jack? Yes. Okay, so let's not do questions as far as can I use this material? Okay, any material in the room can be used. Okay, yes. Don't ask me detailed questions quite yet about the material part. I want you to ask about the challenge. Okay, but yes, for example, yes. Ava?
How long is the minimum requirement of how long it has to be?
As long as possible. What step is left out of here? What word is left out of here?
It's failure.
Failure, right? Yeah. Right? Remember, it was failure. So Ava, you're gonna right here fail, right? Fail, right? So can it always stay up longer? Yes. So as long as possible. Good question, Michael.
Does it have to be like off the ground in any way? Like, what if it's indirectly touching the ground?
No,
It has to be off the ground.
it can only be touching air when it's in flight. Get it into flight, however necessary. Fred.
Will we be creating our model today? Or
So today you're not creating the model. You're going to be here today, and here you're going to be drawing prototypes. But there's much more you need to know about your constraints. One more question, then I'll show you what they are. Yes?
if we were to build it, can we like launch it? Can we stand on something?
Yes. Okay. Okay, we want it to be original, right? Original designs here. Okay, our criteria stays in the air for a long period of time, as long as possible. So I'm going to just note down your constraints. Do that to yourself. Where it says cost, we're going to receive a budget. You're going to have to work around your cost constraints. TBD means to be determined. I will not determine that today. That will come later, after your designs. So you might have to modify your designs in order to meet your budget. What questions do you have now that you see this? Yes? I have scales in front of the room, those black scales. So if you don't know how much is 25 grams, how much is 150 grams, you can test things out right here. You're not testing out anything you're building though today, because you're not building anything today. You're just imagining and planning today and drawing. No construction at all. Yes? Yes. Has to go in an overall forward direction. Anybody have questions about this? What's your question, Zoe?
How are you gonna get it to be 10 miles per hour?
I'm going to have a fan. You're going to have to fly it into the fan. It has to keep going. Okay.
Yeah. I know what I want to do. I have a mini fan in my backpack, and it's electrical. I was wondering if I could actually make it move the paper and move it around. I can hold it and make it move.
No, it has to be in the classroom right now. So no. Okay, so I want to set you off to this up here. We're just in the imagine phase, right? No physical materials yet. Just in the imagine phase. So with this process, all ideas are valid, right? Everything you can possibly say is valid, right? The possibilities are endless. You can make it take off any way you want to, right? It just needs to use the 4 forces of flight, those opposing forces. By the end, we would want to see your design on paper. You're not going to be able to finish the design today, right? But you're going to get to the imagine part. Go.
We got someone. Wait, I got it. Something that we can use. Oh, like air. So do you like those air walks? Like when snakes like hit something. Yeah, something like that. And then I love those things. What if all four? What if you get 4 pies? It's all 4 of us. I don't know if you do that. You get the water bottle and then make the goes
Let's get out this small
around for 2 years.
No, but you gotta think about this. It has to defy 10 miles an hour and stay up in the air at the same time.
It'll just go from like, what if the wings fall off? It'll go, ugh.